TEJ, this lesson goes over how to get analog input from a potentiometer. So one example of analog input would be a thermometer. And the amount of mercury that the mercury reaches shows you the temperature, whereas something that is digital would give you discrete values. Like, for example, an LED is discrete and it's digital, either 0 or 1. You can still represent numbers with it. So here's our browser view. We're going to be looking at a potentiometer. So we'll get in our Arduino to measure in the input. And I want you to notice that there's, in the bottom right, there's analog in, A0 through A5. So we'll be using one of those inputs. And our breadboard. And the potentiometer, I'm just going to type it in. It's just a knob that turns. Potentiometer. So there it is. And it's basically a dial. And as you turn it up, all it is a resistor. It's a variable resistor. That's another name for a potentiometer. And as you know, a resistor limits the amount of current that goes through, and a potentiometer does the same thing, but you can change the value. And if I started it, nothing would happen, but you can move the dial to make it go up or down. I want you to notice that there's 3 legs here. The middle one is the wiper, and we have terminal 1 and 2. So we're going to connect terminal 1 and terminal 2 to positive bus and ground. And well, I'll make it nice and neat. So we'll make this one going to the positive and this one going to ground. Is that neat? This one should be over there. And now it's totally up and down. And then we'll have to let's use 5 volts. Might get more variation that way. So we'll have 5 volts connected to our positive bus. And then we'll have ground connected to our negative bus. Maybe we want to do this to keep it neater, keep the wires shorter. Tinkercad gives you this hinting when it's 90 degrees. All right, so it's connected, and then we just have to connect the wiper to our analog input. So we're going to use A0 as our analog input here. We do have to cross the wires. So analog input, there we go. So now the analog input is connected, and I'm just thinking out loud here, maybe we want to make the wires shorter so we can bring everything down, and then we'll just bring our potentiometer down as well. So that looks a bit nicer, I guess. Okay, so everything's wired up, and now all we have to do is code it. So we're going to use text, so you clicked on code. And we're going to go to code, so text. So go to text. And our pin for A0 will be, it's going to be done a bit differently. We don't need to set up the pin if we're using analog. So I'm also going to take the opportunity here to show you how to use serial input. We're going to erase everything inside of our setup and loop, and we'll say we want to set up our serial bus so that we can see output in the serial. So we're going to say serial.begin. And this is just the baud rate. I believe 9600 will work. It just sets it up so that the Arduino is outputting through the USB cable to the computer a stream of output. And we can say serial.print, and we can say hello world, just to see that what it does. And when we run it in our serial monitor, we'll see it just keeps putting hello world. I use serial.print. You might want to use serial.println And then when you do that, it shows the hello world on separate lines. Otherwise, it stays all in the same line. So that's how we get serial to print out to the serial monitor. To see the output, you're just going to click on where it says serial monitor at the bottom here. If you were using the Arduino programming language on an actual computer using an actual Arduino, it's the same sort of thing. Just from the drop-down menu, you select serial monitor output, and it shows you the same output. All right, so let's get the output from this, and it's all done in the loop, really. We're going to say analog. We're going to read in from the analog input from pin 0. So the command is just analog read. So over here, we're just going to put in analog read, and the commands in Arduino always follow this camel caps notation, where the first word is lowercase, and any other subsequent word of the compound word of a command is uppercase for the first letter. So analog read 0, and when we start the simulation, get the serial monitor up, we're going to want to drag this over so we can actually access and use this dial. So start simulation, and it shows 0, and as I change the dial, you can see that the number goes up all the way up to 1023, which is 1024 is a power of 2, and that's not a coincidence. So this resistor, is it going to show us, if I stop the simulation and click on it, it shows you the resistance is 250 kilo ohms at the top end. And as does it show us how much it is? No, it just says maximum 250 kilo ohms. So if you are going all the way down to 0, it's going down from anywhere from 0 resistance up to 250 kilo ohms. Okay, so there's, we may want to divide this out into values. So here's a way to introduce integers into your code. So we can say int and the document I'm looking at, they're using something called inpin. That's the inpin, and then int val, just set it to 0 for now. So inpin is analog pin number, and val is the current value of the read by the analog pin. So instead of having 0 hard-coded here, we could put in pin, and instead of doing it to print line, we could say val equals. And now we could say, now we could do serial.println val, and just to divide things up. So when we run it, it still shows the same values. So that's how we get an analog input. And I just wanted to show you this. This is a document that I'll have online. I want you to know that PWM is what we're looking at when we're using analog, and we're using analog read, right? Correct. But if we use analog write or analog read, or they're using something called pulse width modulation, and there's a duty cycle. And the way it works is the number is, it depends on how often the value is set to high. So we'll talk about this more with analog write. I think that's the end of this video for now, though.